Okay, so students, we're right here, and it says the measure of the intercepted arc equals the measure of the central angle, and that's true. And a quick picture up here is we got some random circle. The central angle, remember we'll call that theta in degrees. Remember that's always the same right there. Arc measures equal the central angle. All right, that's just a fact. So that first one is true.
Angles do not equal each other. The measure of the intercepted arc equals the measure of the inscribed angle. Again, that's false. And something we're really just using these facts up here. The inscribed angle is half the central angle. The inscribed angle is half the arc measure. So they are not equal to each other. But then we got this last one. The measure of the inscribed angle is half the measure of the intercepted arc. That one's true. And that's what we wrote above. All right? So now it tells me to go back to gizmos, which is kind of save time. I know time is a very valuable thing for you. We're not going to go to gizmos, but what we're going to do is we're going to draw a nice circle. So you still draw all these items. All right, we got some random circle, and I'm going to draw a diameter. All right, and let's just call this, let me try to think, B, C, and let's call this Z, just for fun. We got circle Z with a diameter BC, all right? So something to talk about first is, let's even pick another point just for fun. We'll call that Y, all right? So looking at this arc right here, measure of arc BYC is 180 degrees because it is a semicircle. All right, it's bounded by a diameter. It's half of the circle, semicircle, 180 degrees. All right, now fun fact, we'll do a couple of these. We'll call this A sub 1, A sub 2. We won't go too nuts. I'll call it A sub 3. But it does not matter. Using A sub 1 as a vertex, that's a right angle. All right, using A sub 2 as a vertex, that's a right angle. All right, and last one, using A sub 3, and again, there's infinite amount of points we could have done this for, that's a right angle. All right, so what are the measures of the arcs of the semicircle formed by the diameter? We already said that was 180 degrees. All right, now I'm right here. What is the measure of angle BAC? And look, I picked several angle, or I made up several A's, A sub 1, A sub 2, A sub 3. It doesn't matter which one we pick, it's always 90 degrees. And let's even write, it's a right angle. All right, so if we dragged point A around and made an infinite amount, what's true about any angle inscribed in a semicircle? It's always a right angle. And that's just a cool, sweet, fun fact. All right. And then we got the inscribed angle theorem that we're officially going to talk about now, is right here. And there's a couple different things we could talk about. Let's do this. Let's call this, I like to call it circle Z last time. All right, we got some random circle, circle Z. All right, and do a good job there. All right, let's call that WX, and we'll call that Y. All right, so just to put simple math terms, is the measure of angle WYX, which is inscribed, that's equal to half the central angle, the measure of angle WZX. All right, that's a central angle. All right, that's a fact about it. Furthermore, we could also write the measure of angle WYX equals half the arc measure of WX. All right, That's what's going right there. Basically, an inscribed angle is half the central angle. And then there's a couple other things we could write. We could also write it, well, 2 times the, let's do it like this actually. We could write 2 times the measure of the inscribed angle equals the central angle. And that's true for the arc measure as well. I could also say that it's true for the arc. Again, a lot of letters going on right now. And remember, central angle equals the arc measure. All right, so remember that the measure of angle WZX equals the measure of arc WX. All right, so now let's just do some fun examples. All right, so really fast, well, not really fast, we'll take the appropriate amount of time. We have this inscribed angle. It wants us to find DC. Remember, it's half, so all I got to do is times it by 2. All right, so the measure of arc DC is just 2 times 45, which is 90 degrees. And then in this next one right here, we got the arc. All right, we need the angle. Well, in this case right here, I'm just going to go the reverse. I'm going to divide by 2. So the measure of angle ADB is equal to 76 divided by 2, or 38 degrees. All right. Cruising right along. Now I need the measure of angle ADB. So something to notice too, ADB, ACB. Realize that these angles, let's do it like this. Both these angles are intercepting the same arc. They're both inscribed angles and they're intercepting the same arc. That means that to find both of them, I'm just going to divide by 2. It's literally the same thing, and that's actually a fact, a theorem we talk about in a little bit. That if 2 inscribed angles share the same arc, then they have the same angle measure. They're both 62 degrees. All right? And it's even this fact right here, so let's go ahead and, oops, I'm going to move this fact up here. Copy, paste. All right. If 2 inscribed angles, in this case here, the inscribed angles was angle ADB and angle ACB. If they share the same arc, which was this arc AB, then they have equal measures, which we saw they were both 62 degrees. All right, that's pretty neat. All right, in this one right here, we're gonna find the measure of angle DAB. Now, something we gotta notice is, first let's notice that this right here, this is a diameter. All right, and we've already talked about diameters and the punchlines, what happens because of that. That's a semicircle, so I know this is 180 degrees. But I could have immediately saw that this intercepted arc was bounded by a diameter, thus it had to be a right angle, thus it had to be 90 degrees. All right, so if you can just identify it, it's an intercepted arc bounded by a diameter, then it has to be a right angle, and that's actually Thales' theorem below. And what it says that if an inscribed angle has its end points on the diameter, then the angle is right. All right, and so what that means right here is we just got some random diameter, J, K, L, and then here's M chilling over here. And this angle is an inscribed angle, and its endpoints are on the diameter. Then that's a 90-degree angle, and it's a right angle. All right, that's it. That's the punchline. Pretty freaking cool. All right. Last problem. All right, we're just going to find a bunch of things right here. We're given MP is the diameter. We're going to find the following. So MP is the diameter. Well, let's see what we can immediately find from there. The measure of angle PMN. All right. Which, this has nothing to do with the diameter. PMN is going to relate to this arc measure here. But hold up. If we investigate further, we say that this angle is the same intercepted arc. Shares the same intercepted arc. So to go from here to find this, I'm just going to multiply 68 by 2, and it's 136 degrees. All right? Which means to find that angle, all I got to do is divide by 2, or I could identify that's just the same number. It's 68 degrees. All right? 68 degrees, and I really just found measure of arc PN because of that as well. So cool. Knocked out one thing, or two things I should say. Now I need to find the measure of angle MNP. MNP. Oops. All right. Notice how its endpoints are on the diameter. Thus, I immediately know that this is a right angle. I know it's 90 degrees. All right. And then the last thing right here is just using stuff we already talked about. A lot of chaos going on right now, but we need this angle. This is the intercepted arc, so I'm going to take 92 and just divide by 2. And it's 46 degrees. All right, so that's that. Have a good, or tune in for more.